Okay, take 3. Try again. Okay, and I hope that the people on the screen see anything. We're going to try this, in this group, we're going to be doing things that are more practical, with a less of a focus on halakhic type things. And for today's topic, it's going to be glucose. It so happens that it has what to do with what we spoke about last time. We spoke about davar ma'amid and what's coming in the future. The next side from the other set of shirim, which is to be zer zagarim. That's what sort of made me think to put it in here. Okay, and that's like this. There's something that we call sugar. Something that we... Sorry about the technicalities here, guys. Whoops. Okay, something that we call sugar, and sugar is really something that usually has 6 carbons, 12 hydrogens, and 6 oxygens. It's called C6H12O6, and those are called sugars. Okay, there's a lot of different ones, and the properties that they have to do with how the carbons and the hydrogens and oxygens are organized. All those are details that are not relevant to us. The picture you see over there on the screen, that's a glucose molecule. But there are other ones. There are 4 main ones that we care about. Glucose, galactose, mannose, and fructose. Fructose is also called dextrose. And you'll notice that they all rhyme with each other because they all end with OSE, okay? And that's a scientific thing, that it's not meant to be like lactose. The point is that it's supposed to rhyme. It's supposed to, that means, OSE means that it's a sugar molecule. Okay, so our 4 that we care about are glucose, galactose, mannose, and fructose. Fructose has another name called dextrose. Okay, fructose is a little bit of a different structure than the other ones do, and makes it extra sweet. And you'll hear more about that as we go on.
What is the sugar molecule?
This is a molecule.
It's a certain combination of.
Well, it has 6 carbons. I don't know if you could any of them. 6 carbons and 6 and in a certain shape and a certain style. All those details of what's in glucose and galactose is not so relevant to us. It's not relevant to us for our Kashrus work to know the different things, but they are all sugars and they're very similar to each other. Okay, for our purpose, they're similar. Okay, now the 4 sugars that I mentioned to you, glucose, galactose, mannose, and fructose, those are all monosaccharides. Okay, they have just one molecule. Okay, it's glucose. Okay, the whole thing full of glucose. Like for example, the one we see the most often is fructose, which is fruit sugar. That's why it's called fructose. It's a sugar you find in fruit. So when you eat fruit, it tastes sweet because it has sugar in it. Okay, the sugar that it has is called is called fructose, and it's one sugar molecule at a time. Okay, of course there are zillions of them in your apple. Okay, but that fruit that's in there is one sugar molecule at a time. Okay. Then there are disaccharides. Okay, as you probably guess, a disaccharide means it has 2 sugar molecules that are attached to each other. Okay, 2 that are bound together. Okay, so the way we're going to see as we go on is that the more molecules attached to each other, is the less sweet it's going to be. Okay, but still, a disaccharide is plenty sweet, and there are 3 common disaccharides. Okay, that we see around, and they are sucrose. That's table sugar. Okay, that's a disaccharide. It's not
You're saying table sugar is not as sweet as a fruit.
But it's so different. The difference is so minimal. Theoretically, yes. Okay, sucrose, lactose, that's milk sugar, and maltose. Okay, those are 3 common sugars. And here I'm going to show you what they're made of, just so you see the difference here. Okay, so sucrose, table sugar, is glucose together with the fructose. Okay, it's a disaccharide. And lactose, which is milk sugar, is glucose with galactose. Okay, and maltose is glucose with glucose. Okay.
That's maltose. That's from corn, or is that from?
It's from lots of different things. Okay, we'll see in a second. It's all kinds of things. Okay, now just as an aside, this has nothing to do with sugars that we're talking about. Is that the lactose, which is milk sugar, is obviously milk, because it's dairy. Okay, but lactose and lactic acid are not the same thing. Okay, lactic acid is something that's made usually nowadays through fermentation. We'll talk about fermentations in a minute, and invariably it's going to be para. Okay, and then there's another thing called lactones. Okay, lactones is something totally different. Lactones is a molecule, a certain shape of a molecule, and it has its own Kashrus issues, but it has nothing to do with milk. Okay, so when you see calcium lactate, calcium lactate is not made from milk. Okay, the lact part of the calcium lactate has nothing to do with milk. Okay, it's made from lactic acid. Okay, that's just an aside. Okay, so we had monosaccharides and disaccharides. Okay, you can have one or two sugar molecules attached to each other. Okay, But then they can bind way more than one, two more than each other, okay? And then if it has more than 20, it goes by another name. Then it's called the complex carbohydrate or polysaccharide, okay? And they can have hundreds of molecules attached to each other, okay? Now, there are many different ways that they attach to each other. Again, not so relevant to us, okay? The ones that are out there that are relevant to food production are starch, cellulose, pectin, agars, and gums. Okay, those are all polysaccharides. Those are all sugar molecules attached to each other. Okay, all that I mentioned to you, the one that we're going to talk about, that what we care most about is starch. Okay, and starch is glucose molecules, hundreds and hundreds of glucose molecules attached to each other. All the other ones, cellulose and gums and pectins, are not digestible by the human body. Okay, we can't break them down in our body and get any nutrition out of them. They have all kinds of functions in food, and there's two subperiod articles, if you're curious, 22 and 29. I have talked about those things, but that's not what we're going to care about. It's just about the
starch. We eat things that have them, but
they don't get any nutritional value to.
But we eat.
You eat them, and they're fibrous, and they have functions in the food. Like a gum makes the food be more gelled together. Okay, so it has a function in your food, but it doesn't give you any nutrition out of it. You won't do any better if you eat it on a fast day. Not going to help you one bit if you eat it on tissue. But starch is made up of hundreds of glucose molecules. Okay, just glucose. That's the one that has in it. Hundreds of them, and all these things, the starches and the cellulose and gums, all have to do with the molecules that are in there and the shape that they have, how many branches they have, and all those kind of things, again, which are not so relevant to us. That all the chemistry behind understanding all those things. Okay, so, but yes?
And it might not be relevant, but just, why isn't one monosaccharide automatically combined with another monosaccharide to become a disaccharide?
That's a chemistry question. I don't know the answer to that.
Chemistry.
That's a chemistry question. No idea. So anyhow, for our purposes, the longer the chain is, the blander it's going to taste, and the shorter the chain is, the sweeter it's going to be. Okay, and that's going to be relevant to us. Okay. In a minute, I'm going to tell you all the different ways that glucose is used in industry, in food, in making food and using in food, and that's going to be very relevant to us. But for now, I'm going to first tell you where do we get glucose from. Okay, glucose is very important. We'll see soon how important it is. We're going to talk first about how we get it. Let me first explain to you where it comes from. So the simplest way to get it is from the most, if you think about it, from our perspective, the easiest way to get it would be from a monosaccharide, okay, from something that just has one sugar molecule sitting there waiting for you to take it, like from fruit juice, okay, or from sugar cane or sugar beets or honey. Those are mono and disaccharides. All of those things are mono and disaccharides. So you want some sugar, you take it from honey. Honey is a disaccharide. So honey is a monosaccharide. Sorry, it's glucose saccharide and fructose ones, but they're not primarily not a disaccharide. Okay. Now, there's another item that we need to talk about, which is quite relevant to us, and that is there's another place to get monodisaccharides from, and that is lactose. Remember, I told you lactose comes from milk sugar. Okay, so now to understand its place, I just want to explain to you how it's made. Okay, and that's like this: milk. These are the 5 main components in milk: casein, whey. Those are 2 proteins in milk: casein, whey, fat, water, and lactose. Okay, those are 5. If someone was really writing the main components, they wouldn't have included lactose. But for our purposes, I am including it. There are other minor components, just calcium and other minor things. But the main components are 2 proteins called casein and whey, fat and water, and then also lactose. Okay, that's what milk is made of. Milk is, of course, milkweeds. Okay. No, don't laugh. You'll just read what I'm telling you. Okay, when you make cheese, cheese is the casein and the fat separated out of the milk. Okay, that's what cheese is. Okay. Cheese is also milkweeds. Okay, the other part, what's left over is like a gray water. That's why I try to make the box gray. It's a gray water, which we call whey. It's not just whey. It's whey, water, and lactose. Okay, the Gemara says that there's something called mei chalav, the water of milk, and that water of milk is only milchus midrabanan. It's not milchus midraisa. Some Rishonim hold that whey is what the Gemara is talking about. It's the water left over from milk. When you make cheese, it's the water that's left over. It's this grayish-looking water. And some Rishonim hold that that's considered only milchus midrabanan. Okay, it's a machlokes. We're machmir on that. We treat it as if it's milchus midoraisa. We consider whey to be truly milchus. But then you can separate whey further. Okay, in the times of the Gemara, they used to do it by heating. Nowadays, we do it by filtering. Okay, and the way we do it, which is to filter it, we make two things. We get two things out of that. We get retentate. That's what's retained behind the filter. That's the whey, just the whey protein. And what permeates the filter, it's called a permeate, is water and lactose. Okay? That's what. So we do another split. So when you go to the store and you buy whey powder, it's from the retentate. That's what was filtered out afterwards to get the whey. And everyone agrees that permeate is only milchus d'Rabbanan. When the Gemara says mei cholin is only asur d'Rabbanan, it's for sure talking about that permeate. Okay, so what's relevant, the reason why I told you all of this, sorry that you might be curious, the reason why I told you all this is to tell you that lactose that you get from milk is only dairy midrabanan. It's not asur midraisa. Okay, so the most obvious case is not relevant for today, but for your curiosity, is, for example, if you have lactose and you cook it with meat, that's not basar b'chol midraisa. You can feed it to your pets. Okay, basar b'chol is asur midrabanan. Basar b'chol you can't feed to your pets. It's asur b'ano, but lactose is not asur midraisa. It's only milchus midrabanan. Okay, that was a side point. So now, I just told you a bunch of ways to get sugars from monosaccharides and disaccharides. So that seems to be like an easy way to get them. Okay, but in industry, that's not the way you get them. Okay, in industry we get them from polysaccharides, from starches. Okay, and that is if we have that's my polysaccharide. If you remember my wonderful drawing that I made for you. Okay, if we have a polysaccharide, it's hundreds of glucose molecules attached to each other. We use something called an amylase. Amylase is a kind of an enzyme that works on sugars. It ends with ASE is to tell you that that's what it does. So like this alpha amylase and beta amylase that work on sugars. And now this is going to be very dramatic. And that is the amylase breaks apart the molecule into a zillion pieces. Okay, they all work a little differently. Some break into big pieces or small pieces. All kinds of different ways that they break it apart. But the long and short of it is that, if I can find my mouse, you just get to see me. Okay, the long and short of it is that the amylase breaks apart the polysaccharide into individual or into single or double sugars, glucoses, and as we said last time, for that reason, it's generally considered to be a davar hamayimik because it turns this bland-tasting starch into sweet-tasting mono or disaccharide. Okay, so if you're curious, for anybody who's here, I have an example for that in front of you here. Okay, this is potato starch. This is cornstarch. Okay, this is cornstarch, and if you taste it, I brought spoons if you want. If you taste it, you'll see that it tastes very bland. You can imagine even corn, what does it taste like? Even sweet corn, what does it taste like? It's very bland. Okay. In contrast, once we've broken it apart and it becomes corn syrup, okay, that's what this is. You could taste this. I put spoons here. This is corn syrup. It tastes very sweet.
So corn syrup and cornstarch are made from the same thing?
Yeah, they're both made from corn. Corn starch.
The same part of the corn?
It's from the starch. They took a polysaccharide. Which is the starch, and they attacked it with amylases, different ones, whichever ones they chose to use, and it broke it apart into individual glucose molecules that all of a sudden taste sweet because they're monosaccharides or disaccharides, probably monosaccharides, and they taste sweet.
But there was nothing else that was in that?
No, but it happens to be that in this bottle of carrot soup, there happens to be vanillin added to it or something. There's nothing to it. No, that's all that's in it. It's an enzyme that breaks apart the starch to turn it into a monosaccharide, and voila, it tastes sweet.
But I'm saying it's not like there's by the milk. There were other parts to the milk.
So the milk in the milk we break it apart so we get out the sugar.
Right.
Here
in the sugar, it's all sugars.
In the generic sense, we say yes, they are all sugars. Again, if you taste it, you say this doesn't taste like sugar. It tastes like cornstarch. I mean, it's very bland. It doesn't have any taste, sweetness to it. But it's really because it's hundreds of them attached to each other. If we break that apart, then all of a sudden we have something sweet tasting. Okay, that's a corn syrup. Okay. So the general rule is the halachic status of the monosaccharide made from the starch is whatever the status of the starch was. Okay. So now there are secondary issues like what enzyme did you use and what kalim did you use, but the main issue is what was it made of. So for example, if you get glucose from, what's my examples here? From sugar or from sweet potato, either sugar straight, so you just took a disaccharide of sugar, or you took sweet potatoes, which is a starch, okay, and you broke it apart into its individual sugars, and you made it apart. It will be kashrus pesach, it will be kosher, it will be parav. You could do whatever you want with it. Okay. What happens if you?
Why not?
I'm contrasting that in contrast to what happens if we made a sugar out of grape juice or lactose or wheat or corn. Okay, all of those you can make glucose out of or sugars out of because the grape juice has a monosaccharide and the lactose we said has a disaccharide in it, and the wheat and corn could be broken apart to make them into just a monosaccharide. And what would be the status then? So it came from grape juice, it would be stam yayin. If it came from lactose, it would be milkleeds, and maybe even disaccharides, depending on how the cheese was made. It might even be disaccharides. If you made it from wheat, it would be chametz, and if it came from corn, it would be kidneys. Okay, so depending on what it starts at, what the thing that it came from will tell us what is the status of it when we're finished with it. Okay, so the syrup that we have at the end, the sugar that we have at the end, the individual glucose molecules that we have depends on what it came from. Okay, what the thing was originally. Okay, so where does it come from? In fact, where does it come from? Okay, what do people make these things out of? Because again, I haven't told you yet, but I'm going to come to it when I turn the page to tell you what we use all these things. So why do I care? Why is glucose so important? I keep talking about them. I'm talking for a minute.
Can I just a quick question?
Yes.
Monosaccharide, is it different depending on where it originated from?
Nope.
Is that molecule? None of it's whether it came from corn?
If it's glucose, if it's glucose or if it's galactose, it'll be different. But
right.
Glucose itself, no. The difference where it comes from.
And there's no way to look at it and know
I can't tell you if you can't put it into a lab and figure out which one it wants. But for industry-wise, it makes no difference. If you're using them, they have the same functionality as one or the other. If there's some traces left over, then I can't tell you. But by and large, you can't. It functions the same way. Okay. So where does it in practice come from? So it depends on two things. One is where you are in the world. Okay, so what's going on? Remember, you can make this from any starch you want to or any sugar you want to. So it depends on what there's a lot of. So in the United States, there's loads of corn. Okay, so in the United States, our wheat ends up going for cookies and bread and bagels, and the corn ends up going for things that are generic uses, like this. Like you need to make a sweet, we need sugar, we need glucose, so we make it out of corn. Okay, that's what we have a lot of. Okay, I'm not saying that everybody does, but by and large, that's what it's being made out of. In South America, they have lots of cane sugar. So in South America, their glucose is going to come from cane sugar. Okay, so they just have lots of it. So that's how they make it out. They don't have to break apart a starch. They have a disaccharide to work with. Okay, in the Far East, they use rice and sweet potato and corn. And in the what for us the most significant is that in Europe, there's 50-50 of corn and wheat. Excuse me. So lots of their glucose comes from wheat. And of course, the significance for us is that it would be chametz. Okay, so a lot of the things I'm going to tell you about that you can make with glucose, and there's lots and lots of things that are made with it, then when it comes from, depending on where it comes from in the world, will tell you whether you should be concerned that this is chametz or it's not chametz. Okay, if it's coming from Europe, there's a good chance that thing is going to be chametz. If it's coming from the United States, there's a very small chance that it's going to be chametz. Okay, it's probably kidneys. Okay, now that's one half. The other thing that plays a role in this is market conditions. Okay, that is to say, there was a time when the French government wanted to prop up prices of wine, so they paid people to take their wine and turn it into alcohol. I'm going to explain to you in a minute what that has to do with anything. But they were basically paying them to throw their wine into the garbage. Okay, but to turn it from expensive wine into cheap alcohol. Okay, so they were doing something that was affecting the market. You'll see alcohol has to do with glucose. You'll see in a second. They were affecting the market because of market conditions. They wanted business to work in a certain way. Or in New Zealand and Ireland, they have lots of cows, and they make lots of cheese. And as you saw in the slides before, and poor Yossi missed my good slide about that. No, it would have been for him. So they make lots of cheese and whey, and they get left with lots of lactose. So in those countries, they use lactose as a sugar source, as a glucose source, because they have lots of it. Okay, they have more than other things, and that's what they use. So that's a market issue, which is they have a lot of cheese. You make a lot of milk turns into lots of cheese, and that leaves you with lots of lactose. As a male, those people, there was a dairy question, or even potentially a disaccharides question from the lactose.
Is there an issue with dairy allergens and stuff in the sugar?
That's a good question. I don't think so, but it's a good question. I don't know. Okay, now on to what I keep telling you about, which is what do we do with all this glucose, and why am I talking about it for so long? Why do we care? Okay, what do people do with glucose that makes it different? So here's a bottle of carrot syrup, of corn syrup. Okay, but that's not the main thing that we do with it. Okay, so what do people do with this stuff? Okay, so there's a few things. Okay, and the broadest one is something we call fermentation. Okay, now it's like this. In the human body, if you eat starch, let me take that back. If you put starch into your blood, you get no nutrition out of it. Okay, your body can't do anything with starch in your blood. Your body has to break down the starch into glucose molecules, just like we did with, I showed you with the amylases. Your body breaks it down. In fact, there's alpha amylase in your saliva, I believe, and it breaks it down into glucose, and glucose is what gives you your energy. Okay? Your body stores it and then uses it as needed. That's glucose and insulin. So that's how your body gets energy, is from glucose. Okay? But the human body is not the only one who does that. The human body is not the only person who does it. All living things, or most living things, live off of glucose, including microorganisms. Okay? So a fermentation means is they find a microorganism that either itself has some value, we like that bacteria, something beneficial about it, or it produces something beneficial. And basically, if you feed him, he produces. Okay? So you take a vat full of glucose, and you put into it this microorganism, and either it reproduces because you want more of it, or it produces something that you wanted. Okay? It makes a byproduct that you wanted. Okay? That's called fermentation. So basically, you're taking a big vat full of glucose, and you're putting the bacteria into it, and you're getting out of it vitamin B12, or MSG, or xanthan gum, or citric acid, or a zillion other things like that are made through fermentations. Okay, that's what a fermentation means. Is we put in some kind of a microorganism that somehow was discovered to have some, either we like the microorganism itself, so we want to make more of it, or we want it to produce something for us. We put it into the glucose. It feeds on the glucose again, and it takes energy out of it just like you would take it in your own body. And it either produces something or reproduces to give you what you want to. Okay, so some of those things.
Sometimes it takes something and changes it. Right?
So that's what we call producing something. Okay, so sometimes it excretes it or it changes it around. But for our purposes, from the lay perspective, is you put it in, and tomorrow you come back and there's something else in there. Okay, today it was a big vat full of, so to speak, of sugar, and you come back tomorrow and it's full of something else that somehow is desirable. So some of them. Some of these things you would see on an ingredient panel. Like if there's citric acid in your food, it's going to say that there's citric acid in there. You say, citric acid is made by fermentation. So I now have to know is what's the source of that glucose to know whether this is kosher or not. Okay, or is it more sensitively, is it kosher Pesach? Can I have this thing that has citric acid in it because the citric acid was made by fermentation? Where did they get the glucose from to make the citric acid that I see on my ingredient panel? Okay, where did it come from? Okay, but sometimes it's not necessarily on the label. Like for example, when you make cheese, okay, what turns the milk splits it into cheese and whey is an enzyme called rennet. Okay, and in most of the world nowadays they make that through microbial. It's not a natural thing. It's not something that they find in nature. It's a fermentation. They create the rennet. They put it into a vat of. It's a fermentation. They put it into a vat of sugar and it reproduces, and they have lots of it. Okay, so that. It may or may not, I think it'll say it on the package, but it doesn't have to say that. It's cheese. If it's cheese, there's basically one ingredient in cheese, and that's milk. That's the ingredient you're going to see. But the other ingredient is that there's rennet in there, okay? There's also on the side, there's little cultures, and there's other rolls in there. Those are also made by fermentation. Okay, so then, the reason why a cheese would be not kosher for Pesach is because you want to know how did they grow the rennet, which was mayim the milk, which made it into cheese. Okay, so that's what would be not kosher for Pesach about. I mentioned beforehand also you can make these things out of grape or milk also. So in theory they can be not kosher for other reasons. Okay? Those concerns are not so serious, not so common that you'd make them out of grape juice, or wine or dairy, but it does exist. Okay, so it could be not kosher also for that reason. Okay, but the more serious has to do with Pesach, maybe it's hummus. Okay, so that's a fermentation like in a microbiology type of fermentation. But there's also a common fermentation that everybody knows about. Okay, it's the same idea. It doesn't work like I just described, but it's the same basic idea, and that is when you make beverage alcohol. okay, which is technically called ethanol. I'll call it alcohol because that's what everybody calls it, but the word alcohol is really a technical term. It has to do with a chemical structure. So like this, the end in OLO is like methanol is, it has to do with how many carbons are in the item. So methanol has 1 carbon, and ethanol has 2 carbons, and propanol has 3 carbons. But anyway, what we call beverage alcohol is ethanol. Okay, it's a technical one. Okay, so I'll call it alcohol just because that's what we all call it. So how do you make alcohol? You take grape juice. Grape juice has lots of sugar in it. It's got lots of fructose in it. And you put yeast into it. Yeast takes the sugar and converts it into alcohol, into ethanol. That's what it does. So you take grape juice, you add yeast to it, or the yeast comes in from the atmosphere, you add yeast into it, and you come back a little bit later, and instead of having grape juice, you now have wine. Okay, that's what happens.
Converting the glucose into...
Correct. It's converting the sugar into alcohol. That's what's going on. It's making the sugar into alcohol, and that's what makes your grape juice into wine.
It's not just that you're feeding it, and then it'll burn something else.
Right. You can take whichever way you want to. I'm saying the technicalities are, yes.
Does it make
Yes.
a difference?
Halachically doesn't make a difference, no. No. There were those who argue that it does, but no, it does not make a difference. Now, there's a side thing that I mentioned on the side, is that it does, when it converts it, in this case, yeast doesn't just turn sugar into alcohol. I could have put the formula on the screen. It also, as a byproduct, creates carbon dioxide. Okay, that carbon dioxide in some places is captured and sold to like companies who want to make soda. Okay, well, we say it here, pop. Okay, you want making the soda. Okay, so they want to make it. So they need carbon dioxide. Okay, so that's potential Pesach issues. Okay, that's in step here number 9 if you're curious about that. Okay, and another byproduct of that process is also the leftover yeast. Is called, in case of beer, it's called brewer's yeast. That's an ingredient also. That's a side thing. Okay, so you can make, so wine is the same idea of a fermentation, which is you take yeast, a microorganism, you take the yeast, and it converts the sugar into alcohol. But you don't only have to do that with wine, with grapes. You could do that with other fruit, like plum wine. Okay, that's what plum wine is. It has sugar inside of it. Or you take mead, you take honey, you add yeast to it, and it converts the sugar that's in it into an alcohol. And now you have this alcoholic beverage that's called mead or plum wine or something else like that, or cherry wine, something else like that. Okay, so those are then. But not only can you do that with a something that has a monodisaccharide in it, you could do it with something with starch in it also. Remember, I told you the starches are all polysaccharides. All you got to do is break down the polysaccharide into individual sugar molecules, and then the yeast can do its thing. The yeast can't do anything with starch. If you put yeast into this container of cornstarch, it will go no place. Nothing will happen. The yeast can't break it down. It's not your body that can break it down. It's stuck. It can't do anything. But if you help the yeast, if we first break it down into a monodisaccharide, and then we put the yeast into it, then no problem, and it can ferment it also. Okay, so like you want to make beer, you take barley, you break it down, however, whichever enzyme you choose to do that, either natural enzyme or you add something into it, you break it down, and then you put yeast into it, and it makes beer. Okay, or you take rice, and you break down its starches into the glucose molecules, and you add yeast to it, and they make sake. Okay, so the idea is, once you break it down, you give it, then the yeast can work on it and turn it into alcohol, can turn the sugar into alcohol. Okay, you could then further go and then concentrate that alcohol. Okay, let's say you have wine, so it had 12-13% alcohol in it. Okay, but you don't want to just have 12-13% alcohol. So you can distill it. That's for a different day what distillation is. You can distill it. Basically, you boil it out in a certain way, and you could distill it. And instead of having 12% alcohol, you can have 30% alcohol or 40% alcohol. It's like you concentrate it. Okay. So then we call that brandy. Okay. So you took the sugar, turned it into alcohol, and then we concentrate the alcohol to make it into brandy, like a drink you want to have. Or you take basically a beer, and you concentrate it, and you have scotch. Okay. It's a concentration of that alcohol. But in industry, there are people who not only do it concentrated to make it a stronger concentration, they concentrate it to pure alcohol. Okay, they boil it out that it's completely 95% alcohol. And so, vodka is the second step of that. They first make pure alcohol. Vodka then is the watered down version of that. They take that pure alcohol, it's called grain neutral spirits, because you can't tell where it came from, it's pure alcohol, and you water it down, and that's called vodka. Okay? But for industry, they sell that as alcohol. Okay? Companies that need to use alcohol we'll see some more uses of alcohol in a second. So who you want to use that alcohol is someone can concentrate it from a regular fermentation. They need wine. The wine is concentrated on and on until the point that it became pure alcohol. So I told you that in France they wanted to get rid of the wine. They wanted to keep the market, the prices propped up. So they had them concentrate their wine to the point that it was pure alcohol, and that alcohol could be sold to people to use in industry as pure alcohol. It's called ethanol. Yeah, it's called ethanol. Well, I keep using the word alcohol, but in this case I don't mean ethanol.
They would sell it as ethanol, right?
They would sell it as ethanol, whichever one. Yeah, they sell it as ethanol. Okay, so now, back to where we're starting from is the glucose that was in there in the beginning, in the grapes or in the milk or in the starch or whichever it was, now turned itself into alcohol, which it became to an alcoholic beverage, but then it could be further concentrated to the point that it's pure alcohol. Okay, so that's another place where we can end up, where our glucose can go. Okay. Okay, I have a note here that says, this is one way to get alcohol. You can also get alcohol. Can also be the pure alcohol can be derived from petroleum sources. So I keep telling you how it's made from food, which is true. And most of the food sources don't pose any kashrus concerns. Okay? Most of those food sources don't cause any concerns. But there are like chametz ones and a little bit of non-kosher sources. But there's also petroleum sources. Okay, and here just a word thing also is that ethanol is alcohol made. It has that structure. Ethylene is something that's made from petroleum. It has nothing to do with ethanol. I mean, it's similar, but nothing to do at all with ethanol. Okay, so ethylene is made from petroleum, as opposed to ethanol, which could come from either. Okay. Further, if we take this alcohol and we ferment it a second time. Okay, we're using a different bacteria. This one has a fancy name. This one's called acetobacter. We use another bacteria. Okay, and we could turn alcohol into vinegar. Okay, essentially, what we're doing is we're converting the bacteria is converting out the ethanol into something called acetic acid. Okay, so so we put in this enzyme, or it comes in from the atmosphere. Like if you leave your bottle of wine open, it comes from the atmosphere, and it sours your wine. Okay, that souring it's turning the alcohol, the ethanol, into acetic acid, and it makes it taste like vinegar. Okay, so the simple way to do that is, well, the way they did it, 100 years ago was you took wine. So if you take your wine in your house and you let it, and it sat for too long, it would turn into wine alcohol, into wine vinegar. You do it a hard apple cider, then you get apple cider vinegar. Again, you took apple juice. So we start with apple juice. It has sugar in it. The yeast turned the sugar into hard apple cider, which was alcoholic apple juice. Okay, turn the sugar into alcohol. If we do that one more step, then the alcohol that's in the hard apple cider turns into apple vinegar. Okay, so what we call it wine vinegar. Sorry, apple cider vinegar.
So all vinegar had to go through the stage of being
alcohol. Yes, that's what vinegar is. It's sugar that turns into alcohol, and alcohol that turns into vinegar. So you have rice wine can turn into rice vinegar. Okay, people have rice vinegar with their sushi. Okay, so that comes from, it started as rice. The rice was hydrolyzed. It was broken down into sugars. The yeast worked on the sugars, turned into alcohol. And another bacteria worked on it to turn into vinegar. Okay, and then it ended with the rice vinegar. Okay. And so then there's a more modern invention, which is white distilled vinegar. Okay. White distilled vinegar is if you have grain neutral spirits. You have alcohol that was purified to be basically 100% alcohol. So the point that you can't tell which grain it came from. If you turn that into vinegar, that's white distilled vinegar. Okay, it's not like apple cider vinegar. It has no color, has no taste of anything else. It's just pure vinegar.
And you can also make vinegar out of the petroleum.
Okay, I was going to say that. That there is there's something else. I've mentioned in passing that vinegar is acetic acid. Okay, so when vinegar in your house is 5% acetic acid. That's a legal thing. Okay, the vinegar in your house, you look on the bottle and see it says 5% acetic acid. That's how much is acetic acid, and the rest is other stuff, water and whatever else is in there. You could also make from petroleum, you can extract from petroleum 100% acetic acid. Okay, it goes by a name called glacial acetic acid. Okay, not 5% acetic acid, it's 100% acetic acid. Okay, so in theory, you could take that and make something that's like vinegar. You dilute that in 95% water and 5% glacial acetic acid, and you can have something that's vinegar-like.
Is that edible?
Yeah, you can eat that.
You know, it came from petroleum.
You'll eat lots. Whether you like it or not, you eat lots of things that come from petroleum. So yes, you can.
It's not really a difference, right? It's the same thing. It's the same exact thing.
Yes. Technically, it's the same thing. It's not common. I'm not sure if you're legally allowed to call that vinegar. I'm not sure if you're allowed to call that vinegar. Then I'm not sure. Vinegar may have to come from like a food source, but it has the same effect as vinegar. So if you want, so now to the Kashrus concerns of all kinds of condiments, ketchup and pickles and dressings and things like that. One of their concerns, which is the vinegar, is where did it come from? Which is to say, not the vinegar. It started way back when as a sugar or a starch. So it started as a starch, then it was converted to a sugar, and then the sugar turned into alcohol, and the alcohol into vinegar. Okay, and so our Kashrus concern is way back when. Did that vinegar start as wine? Did the vinegar start as chametz? Or did the vinegar start as potatoes?
It became.
Then it holds on to that status the whole way through, right? It went through a whole bunch of steps here, it holds on to that status. Okay, now, vinegar is a drop different than alcohol in one detail, and that was like this. Most companies that make alcohol out of a grain or a sugar, that's what they do. They don't switch from one to the other. It's not easy to switch from making from wheat to making out of corn, or from corn to making out of wheat. It's not on a dime that today we're making corn, tomorrow the price went down, let's make it out of wheat. Okay, they don't work the same, and whatever they're doing tends to be, they do the same thing every day. As opposed to vinegar companies, it's just the opposite. Almost every vinegar company all over the place makes white distilled vinegar and wine vinegar. It's very common. They're making both at the same time. So now there's kalim issues, which is they're sharing the same equipment for both of those processes, or some of the kalim are being shared for them. So there's much more of a question of kalim on a vinegar than there is on alcohol. And the alcohol, whatever they're doing is what they tend to be doing, as opposed to in vinegar, where it's more, it's very common that they're doing wine vinegar, which is not kosher, of course. It's sanyayin, and regular vinegar. Okay. Let me skip something. I'm almost done. Okay. There's another thing we could do with alcohol. I'll just mention basically the one that I skipped, well, partially.
Just 1 second.
Yes.
If they make vinegar out of alcohol-based petroleum, they still have to do it with acetobacter stuff using bacteria?
Yes, if you start with it, if you have alcohol, you want to make alcohol into vinegar, you have to put an acetobacter. You put it into an environment of an acetobacter, and that's what changes it. It won't change by itself. I mean, if it changes by itself, it's because it came in from the outside.
That's a process of fermentation. Mm-hmm. But to make alcohol out of petroleum, you don't.
Correct.
They don't
No, you just go down Texas and you just drive on the side of the road. That's what they're doing. Okay, so there's also all the ethyl. I'm mentioning about ethanol and alcohol and vinegar. There's all the ethyl compound, like ethyl butyrate. Okay, ethyl butyrate was made with ethyl alcohol. Okay, with ethanol. Okay, that's what it was made from. Okay, what is ethyl butyrate? It's a flavor chemical. So there's a lot of ethyl compound things that are made with ethanol in them. Okay, and there are extractions done with ethanol. Okay, like CBD oil can be extracted with ethanol. Okay, now one more thing is something called sugar alcohols. And that is, you could do a process called hydrogenation. Not so important what that is. Do a process called hydrogenation to turn a sugar into a sugar alcohol. Okay? It retains a lot of the sweetness of the sugar. A lot of the sweetness stays behind, but all of a sudden it has new properties. Okay? The most common one that we see is sorbitol. Okay? So here's the trick here. All these end with TOL. Okay? Sorbitol. Okay? And then it's going to be mannitol and maltitol. And they all end in TOL. Okay, and so sorbitol is the sugar alcohol made from glucose. You take glucose and you hydrogenate it, that makes you sorbitol. Okay, so now what its most famous, two famous features that it has is, first of all, is these tend to have less calories. Okay, one thing is they tend to have less calories than the actual sugar itself. So some of them are used as for dietetic reasons, diet reasons. But the other thing is that sorbitol doesn't grow cavities on your teeth. Okay, if you put sugar onto your teeth, then bacteria will live there who will eat away at your teeth. So you don't want to put that onto your mouth. As opposed to sorbitol, tastes sweet, but it does not grow. Whatever it is that makes you get cavities in your teeth doesn't happen from having sorbitol.
Bacteria make you get cavities in your teeth?
Whatever it is, there's something that grows on there. I don't know if the technical word is bacteria. Whatever it is, doesn't like sorbitol. Okay, it likes regular sugar, but not sorbitol. So, for that reason, sorbitol is used in almost every single toothpaste that's out there, okay? Because it makes the toothpaste taste sweet, because really the toothpaste is awful stuff that you're putting on your teeth, okay? You wouldn't want to put it in your mouth, but you put in sorbitol, makes it taste sweet, okay? But you wouldn't put sugar in. That would be pretty silly to put sugar in. You're brushing your teeth and then encouraging that cavity. That would be pretty silly. So instead you put sorbitol, okay? Well, so again, where did the sorbitol come from? Sorbitol is a sugar alcohol. It's made from glucose. Where did the glucose come from? So now, back then, we're tracing that glucose back to wherever it came from, often a starch, and that's the reason why we tell people that toothpaste needs to have Hashgachah for Pesach. It's because invariably the question is the sorbitol that's in there. Almost every toothpaste has sorbitol in it, and the sorbitol that's in there, it's a question, where did the sorbitol come from? What do you mean, where did sorbitol come from? Sorbitol came from is a sugar alcohol, so we hydrogenated glucose. That glucose came from a starch. If that starch was wheat, then we're in trouble, and we have a problem, then it's chametz. Okay? And now, as I told you beforehand, most of the places in the world don't do that. Most places are not making it from wheat. They're not making the glucose from wheat. But if they are, then we have a chametz problem, that these things would not be okay. The sorbitol itself is one of the things that's used to make vitamin C. It's also a Pesach or a Kashrus also. And sorbitol is another thing that you may have heard of, which is it's turned into polysorbates. Okay, the sorb in polysorbates is from sorbitol. Okay, and that is polysorbates are sorbitol with a fatty acid put together. Year round, the Kashrus issue is the fatty acid, and Pesach-wise, the issue is the sorbitol. Okay. One more thing, I'm really done. I have this much left, and that's to tell you that there's one thing I'm not going to talk to you about, and that is I'm just going to tell you about it. I'm not going to talk to you about it, and that is that that I told you that whatever the starting material is, the finished product has the same status. Okay, there are reputable hashgachas that say that if the change that happens between the original starch or the original sugar and the finished product is very dramatic, like if you turn corn syrup into citric acid. Okay, so the sugar is sweet and the finished product is sour, citric acid, it has a sour taste to it, so that's a dramatic change in taste. That qualifies as something called Nishtaneh. Okay, Nishtaneh means something changes dramatically. It's machlokes Rishonim what the din is about something that's Nishtaneh. And they say, and if the thing that it started with is only Asr Midrabanan, then in that case we'll be makel and say that Nishtaneh is mutar. So there's two steps here. One is it has to be Nishtaneh. The change has to be dramatic, not a change like going from sweet to sweet. Let's say from sweet to sour, or something very dramatic, a big change in the thing. Secondly, it has to be something that's only Asr Midrabanan. In that case, if it's both of those things together, then there are reputable hashgachos who will say is that item loses its original status. Okay, and the two applications of that are if it comes from kidneys is only a minute, it's only at most midrabanan. So they'll say kidneys shenishtana. If we change something, let's say we take corn syrup, this carrot syrup, and we turn it into, we use the sugar that's in there to make citric acid. We'll say that citric acid is kosher Pesach. Okay, even though it started off as kidneys, it loses that when it was nishtana. The other example is what I told you beforehand, which is why I put on the screen, lactose. If lactose is only milchus with rabbanan, and I told you, so if it's assuming that it's kosher, it could be lactose that's vinaccharides also. I guess it's only milchus with rabbanan. But if it's only milchus with rabbanan, then they'll say if that is turned into something that was considered nishtana, it had dramatic enough change to be considered nishtana, then that will not be milchus anymore, and it becomes par. Okay. We're not going to talk about what that was. I spoke about it before Pesach. I looked it up in 2012, if you want to listen to the recording. But in Eretz Yisrael, they don't accept that. In America, certain hashgachas don't accept that, and particularly Hamish ones. But there are reputable hashgachas who will tell you...
Who accepts it? Kidneys, but that's a minute. Was there anybody who said that we...
For lactose? Yes.
Yeah.
Yes, we do it for lactose. Yeah, we do it also. I don't know that we in practice do it for lactose, but if it came into us, a lactose, we would take it. Kidney is also the same thing. Kidney Nishtaneh we would take, the CRC would take. And it's quite a to-do. You can listen to the recording from 2012. But that's like beyond, that's not for today. Just forgot how to mention it. Okay, thank you.